So we want to prove this identity, and actually this is a pretty tough 4 marks. Usually when adding or subtracting fractions, the thing is to try and get a common denominator. And if you try that here, you'll end up with a bit of a mess. And I think that that's not the way to go here. So I'm going to start with the left-hand side. And I can just see this mess coming, but I understand why a student who hasn't done as many of these as I have would just try and get the same denominator and then end up with a mess. But I can kind of see that coming. So what I'm going to do is I'm going to say, well, that tan x is actually a sine x over cos x. And then here, because we know that cot x is 1 over tan x, that makes it cos x over sine x. And so with this first fraction, if I multiply it top and bottom by cos x, on the top I get cos squared x. And if I multiply the bottom through by cos x, I get cos x plus sine x. With the second fraction, I'm going to multiply it top and bottom by sine x. And I get sine squared x. And then multiplying the bottom through by that, I'm going to get sine x plus cos x. So we have got the same denominator, you note, but it's just not by simply multiplying the two denominators together. So now I have cos squared x minus sine squared x over cos x plus sine x. And now the marks are easy to get, but only because we started the right way. We've got a difference of perfect squares on the top, so we've got cos x minus sine x, and then we've got cos x plus sine x, and all of that is over cos x plus sine x, but then we see that that will cancel with that, and so we end up with cos x minus sine x, which is the right-hand side. So now we want to solve this equation in the range given. And we've just established that the left-hand side of this is cos x minus sine x. Now, bear in mind that even if you couldn't do the first part of the question, you can use that identity to rewrite this as cos x minus sine x. So it's equal to 3 sine x, take away 4 cos x. And we're solving in this range here. So let's bring the sine x's to one side. So 4 sine x's, and the cos x's, let's get those all on one side. So we'll have 5 cos x's over here. And then dividing both sides by cos x gives me 5 equals 4 tan x. And so tan x is going to be 5 over 4. So our principal value is going to be the inverse tangent of 5 over 4. And I think my calculator's in radian mode and we're solving in degrees. So let's just quickly change to degree mode. And then we'll do the inverse tan of 5 over 4. And that's 51.34 degrees. So that's our principal value, and that enables us to draw a cast diagram. And 51.34 is here. Tangent that's positive, the other one's going to be down there, and the associated acute angle would be 51.34. And then we're doing negative 180 to 180. So we'll start at negative 180 and we'll come forward and we meet a solution. And so that solution would be negative 180 plus 51.34. And then we keep going and we meet the 51.34. And then we keep going and we get to the point where we stop at 180. So we have negative 180, add 51.34, and that is negative 128.66. Let's call it 128.7, and then we've got 51.3, giving both of those to one decimal place.